Hi guys, I hope you are fine. Guys, let's look at this problem and see what you can do about it. This is a Fourier series problem. And I read the question. Given the function fx is equals to, open the bracket, minus pi minus x, the limits are negative pi and 0. Then you have negative pi plus x, limits being 0 to pi. And then you have this as the period, the 2 pi, that is from negative pi to pi. Sketch the graph for 2 periods. Determine the Fourier series of fx. By setting x equals to 0 in the series, show that pi over 2 all over 8 is equals to summation, and this is summation from, that is from n equals to 1 to infinity. So that's what we are going to do, guys. So let's start our question, guys. So guys, I have already prepared to start the question and I've already done some parts, and let me explain to you as we continue. So this is the problem we are talking about, and I have come here and drawn the graph from this. I create a graph here which is a linear graph. So when I put negative pi there for this is going to give me negative pi plus pi, which is 0. For the 0, when I put there, it will be negative pi. And then coming to this other side, that is from 0 to pi, if I put 0 here, you shall have negative pi. If I put pi here for x, this one is going to be 0 because minus pi plus pi is 0. From there, guys, I come and now draw the diagram. And this is how I drew it. That is, now I come to my points here. 0, starting from negative pi, you have negative pi 0. So this is the first, that was the first point. The second point is 0 and negative pi. 0 here, and here is negative pi. So this was my other point. Coming to this one, you have 0 and negative pi. 0 and negative pi still the same point. Then you have pi and 0. This was not my point. Then guys, I had to join those two little points by that. And now guys, we are told to draw yet another, like 2 periods. This is one period. So the other period can come from there to there, whereby this one is supposed to meet, guys, this is supposed to be at this point there. And then guys, this one goes to this point, which we call now, this is now 3 pi. So these are our 2 periods, guys. They don't look so nice, but since I have drawn by hand, so these are the 2 periods. Guys, I now go to doing the question. The first thing, guys, we establish the equation that is used. And the equations that are used are as shown. We have fx, that is the series. This is equals to a0 all over 2 plus the summation from n equals to 1 to infinity. This is an even function. Guys, this is even because it's symmetry along the y-axis. So this is an cos nx, like that. So guys, after that, we establish our an, our a0 first. This one will be like integral from now 0 to pi, 0 to pi, and because of that, guys, we are going to have here 2 all over pi, 2 here all over pi. So that is our formula, and this one we have fx dx. For the an, we have an equals to 2 all over pi from 0 to pi fx cos nx dx. So guys, now we go into action. So we come and write a0. This one gives us 2 all over pi from 0 to pi. And the equation we use, guys, is the first one, the second one, because from this point to this point, that is from 0 to pi, then it's already multiplied by 2 as we do the equation. So this one will get negative pi plus x. That one, now we find the dx. So coming to that, guys, this is what we are going to have. So guys, I have already done that for you, whereby I have integrated that, whereby this will be pi x plus now x squared all over 2, and the limits are 0 to pi. So when I put the limit, guys, I'm going to find this, and then you multiply by 2 all over pi, and then you get your a0 as negative pi. Next, guys, we are going to look for an equals to, that is, we still use the same equation, but different in a way, because we are now going to have negative pi there plus x, and this is now going to be cos nx dx. So guys, that's what we are going to have. And this one, guys, we will employ integration by parts. And so guys, let me do it and I show you. So guys, we continue from there, and this is how I have done it. I've got this is integration by parts. This is u and this is the dv. So that du is equals to dx for that, and then the v for that is supposed to be 1 over n sine nx. And so guys, I have come here and put that into place, whereby this is now u, and this is now going to be v, and here we have, and remember this v, the n, I have factored it out, and then we say minus, this is now going to be dv, which is sine nx, and then we have the du there. I have also factored out the n at this point, and I brought it forward here. So guys, from there now, we have this equation now for that, which now, guys, if you look at it very closely, this one is now going to be 0. If you put pi here, guys, and you say sine 180 for n equals to 1, this one gives us 0. For 2, the same, and for 3, the same. So this one, guys, is 0. Then we are left with that one, guys. For that one, guys, when we put 0, this 0 will give us 1. This is the 1. And then, of course, this one we factored out the n, so that here we have n squared, and then here we have 2. So when we put pi, this is what we got. And now, guys, we come and put numbers. If we try the even numbers, you find that cos pi, for example, cos 2 pi, for example, will be 1. And this is how. So let's see for even numbers here, that is cos 2 pi, that is 360. You get 1. So 1 minus 1 is 0. Now we go for the odd numbers. Let's say 1. We'll have cos 180. This one gives us negative 1. Negative 1 minus negative 1 gives us negative 2. when you multiply now, you get, multiply by 2, you get -4. So this is what our term, guys. And now, guys, before we now come to this equation here, so that we can make this one to have this n as odd number, this is how we are going to do it before we place it here, guys. We shall say n is equals to, you have 1, guys, and you have 3, you have 5, and you can continue like that, guys, until we come to nth term. For the nth term is usually written as, this is now AP, A plus n minus 1 D. That is the nth term. And so let's see what it is now going to bring about, guys. So we shall have our first term for that, for this n is 1. So we shall put A as 1 plus n minus 1. N is what we do not know, but guys, we know the D. D is supposed to be 2. The common difference is 2. So this is going to be nth term. And so this one, if you work it out, guys, you're going to have 1 plus 2n minus 2. This one now gives us 2n minus 1. And so, guys, we come and now we have here n squared. So this is now going to be squared. So we put it like that. And so, guys, as we come, we shall say now our fx is equals to the a0. A0 was negative pi. So it will be negative pi over 2 plus, we put that summation there, n equals to 1. And here we have the infinity. And then for an, we have this. Guys, we have this. So we are going to put this in front here. So I can put -4 here. All over pi. Like that. But now my n, I will put this. So I have 1 all over 2n minus 1 squared, and I now put cos nx like that. After I have put like that, guys, I can now say that this now, guys, represent the series. But now, guys, so we can say this represent the series in short. But now, guys, let's look at this and ask ourselves for this question. We see what we can do about it. By setting x equals to 0 in this series, show that. So, guys, we are supposed to show that pi squared all over 8, this one is equals to, from n equals to 1 to infinity, here we have 1 over 2n minus 1 squared. So this is what we are going to work out. So, guys, we are told f is supposed to be x, not x, but x is supposed to be 0. So when x is equals to 0, guys, we come to our diagram here and check, because this is along this axis is where now our x is. X equals to 0, so fx, guys, is going to be -pi. So we shall have f0 is equal to -pi, and now this is now equal to -pi all over 2 plus, this is now going to be minus 4 all over pi. Let me first of all write it. So now guys, we can bring, before that, the cos now will become 1 because now you'll have x equals to 0, cos 0 is 1. So here we shall have 1. So guys, now from there we bring this negative pi over 2 this side. So when you bring it, it will be positive. Negative pi minus plus pi over 2. This one will give us negative pi all over 2. When you bring this one this side, negative pi plus pi over 2 gives us that. This now is equals to negative 4 all over pi. Then you have the summation as usual, n equals to 1. This is infinity. 1 all over 2 n minus 1 squared. So guys, this negative can cancel. I can bring this pi here. So you have pi squared. I can also bring this 4 here. You get 8. So guys, we have been able now to prove what we were asked to prove. So this is our solution, guys, and thank you so much for listening to me, guys. And I can now say this problem is solved. Thank you.